Good morning, students. Our today's topic in the topic of Newton's laws of motion in the subject of mechanics A levels is motion caused by several forces. So concentrate yourself. We are going to start. We have seen that if an object is moving in a particular line, we can analyze the motion by collecting the forces in that direction. However, in the example so far, the given forces have all been either vertical or horizontal, so that the collecting them was simple arithmetic. Now we look at more realistic situations where the forces on an object act in various directions. So here is a question that will make your concepts more clear now. A body of the mass 3 kg is sliding down. So this is 3 kg. So the weight will be 30 Newton because W is equal to mg. So m into g 10 will be 30 Newton. So a body of the mass 3 kg is sliding down a smooth plane inclined at 30 degree. So here is the 30 degree to the horizontal. So it is moving down. Find the acceleration of the mass. So concentrate yourself now. Acceleration is the requirement. So resolving this force into its components, so it will be W sine theta because this is W. So W sine theta is along the plane and W cos theta is perpendicular to the plane. So W sine theta is the vector that is responsible for the motion of the body. So look now, the diagram shows all the forces that act on the body. The body can move in only one way, that is down the plane. So the acceleration is marked in that direction. So here will be the acceleration. The acceleration is caused only by the components of the forces that act along the plane. So these must be found and collected. So the component of the weight or the force along the plane is W sine theta. So this is the component of the force which is along the plane, and W cos theta is perpendicular to the plane, that is opposite to the reaction. And here is the resultant of these two components. So again look, W sine theta is responsible for the movement. So this is the resultant force now. So it means W sine theta, that is 30 sine theta, is equal to ma because this is the resultant force. This is the formula that is going to be used. F is equal to ma. So F is the resultant force, that is W sine theta is equal to ma. So m is 3 kg, which is given in the question, and A is the requirement. So this will be the step now, and from here you will solve it on the calculator. This 3 will come to the denominator of the 30 sine 30 degree. So you will get the answer when you will solve it on the calculator. So acceleration of the mass is 5 meter per second square. Okay, the B part of the question is, show that the normal reaction exerted by the plane on the mass is 26 newtons. So this is the thing which we have to prove. Correct to 3 significant figures. So this is the reaction that is required, that should be equal to this one. So look now, there is no acceleration in the vertical direction. So concentrate yourself now. As there is no acceleration perpendicular to the plane, the resultant of the forces in that direction is 0. So it means the reaction of the plane should be equal to the vertical component of the force, that is W cos theta. So this is the vector which is exactly opposite to the reaction. So it means R should be equal to W cos theta because there is no vertical acceleration in the body. So look now, W cos theta is equal to R. So W is 30, cos 30 degree, because angle is 30 degree given, is equal to R. And when you will solve it on the calculator, this will be the answer up to 3 sig fig. So this is proved now. Here is another question. The statement of the question is a cyclist is riding up a hill inclined at 20 degree. So here is the 20 degree, that is a hill that is inclined at 20 degree with the horizontal. A cyclist is riding up to the horizon. Okay, her speed at the foot of the hill is 10 meter per second. So this is the speed at the foot of the hill, that is given 10 meter per second, and after 30 seconds later it is 4 meter per second, and the final speed will be after 4 seconds 4 meter per second, after 30 seconds will be 4 meter per second. The total mass of the cyclist and her machine is 100 kg. So this is the weight. Total mass is 100 kg. So it means 100 into 10 will be the weight of the total cyclist and the machine. And the resistance to the motion acting on the cyclist and her machine has magnitude 15 Newton. So this is the 15 Newton, which is the resistance resistance to the motion acting on the cyclist and her machine has magnitude 15 Newton. So this is the force which is resisting the motion of the cyclist. Find correct to three significant figures the constant driving force exerted by the cyclist up the slope. So this driving force is the requirement, and definitely the body is accelerating up the hill. So acceleration will be in this direction. So concentrate yourself. This is very important question. So first we have to find the acceleration of the cyclist up this slope. Look now, the initial velocity is given 10 meter per second. Final velocity is given 4 meter per second, that is here. Time given is 30 seconds. So is the requirement. So first we will use the first equation of motion, that is V is equal to U plus AT. Now putting these values into the formula, so A will be equal to this one. Solve it on the calculator, you will get the answer. Acceleration will be negative because the acceleration of the body is slowing down. Definitely the acceleration at the foot of the hill will be greater, but as the body is moving up, acceleration will be slowing down. That's why a negative sign is here. This shows the acceleration is slowing down. The cyclist has an acceleration of -1/5 meter per second square, because meter per second square is the unit of the acceleration. Okay, now question is find correct to the three sig fig the constant driving force. So this is the driving force that is required. So concentrate yourself now. So driving force minus 15, because 15 Newton is the resistance that is trying to resist, that is resisting the motion. So that's why this factor will be subtracted from the driving force. Also W sine theta is the component of the force that is parallel to the plane. So W sine theta will also be subtracted. So D minus 15 minus W sine theta will be the resultant force, equal to MA. M is 100 kilogram. So look now, D minus 15 minus 100 G sine theta. So this is the component of the force that is parallel to the plane. So that's why these two factors will be subtracted from the driving force, equal to MA. M is 100 and A is -1/5. So putting these values into the formula, solve it on the calculator, you will get the answer. So this is the driving force that need to move up the hill according to the data. The cyclist driving force is 377 Newton according to 3 sig fig. Here is a question. The statement of the question is the diagram shows a small block of mass 2 kilogram being pulled up. So it is being pulled up a plane inclined at 30 degree to the horizontal. The block has an acceleration of 0.5 meter per second square. So this is the acceleration. The requirement is find an exact expression in terms of G for the tension in the string if A part the plane is smooth and B part, the plane is rough and exerts a frictional force of 4 Newton. So in first part, the plane is smooth, so there will be no friction. And in second part, the plane is rough and exerts a frictional force of the 4 Newton. So now come to the board. We will solve this question on the board now. So this is the figure of question number 1. So a mass of 2 kg is moving up at an inclination of 30 degree. Acceleration produced is 0.5, and in A part it is given that the plane is smooth. So it means there will be no friction. So this is the components of the weight W, that is W sine theta. This is the vertical component to the plane, that is W cos theta, and this is the weight W. Okay, now this is the vector which is applying parallel to the plane. So no friction is there in the A part because it is given that the plane is smooth. So this is the only factor which will be subtracted from the tension in the string, that is W sine theta, should be equal to MA, because this is the resultant force. Okay, from here it is also given that the answer should be in terms of G. So it means you will not put the value of the G. So W is equal to mg. So mass is 2 kilograms. So 2g sine theta is 30 degree will be equal to ma. So m is 2 and a is 0.5. So now this factor will go to the right hand side and will be added in this one. So T is equal to 2 into 0.5 will be 1 plus 2g and sine 30. So sine 30 will be 0.5. And when you will solve it on the calculator, this factor will be solved on the calculator. You will get 1 plus 1g. So the answer is 1 plus g Newton. Okay, in the B part, it is given that the plane is rough and the frictional force is 4 Newton. So it means now 4 Newton and the component parallel to the plane will be subtracted from T. So look now, this will be the thing, T minus W sine theta minus frictional force, that is 4 in the second part. So this will be the resultant force, will be equal to MA. Okay, from here now you will put the values T minus, because again it is given, it is required that answer should be in terms of G. So 2, because W is equal to mg, m is 2 and G is still there, and W sine 30 is there, minus 4 should be equal to MA, M is 2 and A is 0.5. Okay, now you will send these two factors to the right hand side. So T will be equal to, this factor will become 1, this factor will also become 1, and this plus 4 is still there. So you will solve it on the calculator, you will get the answer 1. Okay, and this is 2g. So this will be, this factor will, when it will be solved on the calculator, this answer will be 1g, and this minus 4 will go to the right hand side, it will be plus 4. So 1 plus 4 is 5. So 5 plus g Newton will be the force will be the tension that is required to pull up this object up the hill. Here is another important question. The block of the mass 20 kg is dropped from a balloon that is moving horizontally with a constant speed of 2 meters per second. So a block of mass 20 kg is going to be dropped from a balloon that is moving horizontally with a constant speed of 2 meters per second. There is no air resistance. Okay. Here are the requirements. Mark on the diagram the forces acting on the block as it falls. Okay. Second part is what is the vertical component and the horizontal component of the acceleration of the block. So remember, the balloon is moving with a constant velocity, that is 2 meters per second. C part, without doing any further calculations, sketch roughly the path of the block as it falls. So these are very easy parts. So in first part, mark on the diagram the forces acting. So the force will be only weight, because that is going to be dropped. Okay, that will be free fall then. There is no air resistance. Keep all these points in your mind. Second part is the vertical and the horizontal components of the acceleration is the requirement. So because the balloon is moving with constant velocity, so the horizontal component of the acceleration will be 0, because the balloon is moving with constant velocity. The vertical component will be there, that will be equal to the acceleration of the gravity, that is 10 meters per second square. Okay, the final part is without doing any further calculations, sketch roughly the path of the block. So when something is dropped from the moving horizontally balloon, so the path will be like this, a projectile motion. So come now, we will solve it on the board now. So here is the figure, a balloon and an object of 2 kg is going to be dropped. So in A part, the forces acting on the block will be the weight W in downward direction. In B part, it was required find the components, find the horizontal and the vertical components of the acceleration. So the horizontal component will be 0 meter per second square, and the vertical component will be 10 meter per second square, because the acceleration of the gravity will be applied. Okay, in C part it was required that without doing any calculation, sketch the path of the object that is going to be dropped. Okay, imagine that from a moving plane that is moving horizontally with a constant velocity, something is dropped. So the motion will not be exactly vertical, that will be like a projectile motion. So that will move like this. So this kind of the motion will be there. So this is a sketch of the motion when the block will be dropped from the balloon that is moving with constant velocity, that is 2 meters per second. So this will be the projectile motion of the object.